All right, so last example for the section 1-1 here is example 5. And now we're going to add in rate of change on an interval. So instead of talking about what this is talking about here, I want to just give you a quick overview of what rate of change is. So the letter we use for rate of change, this is probably going to look familiar, is M. We also refer to it as slope. You probably spent a lot of time in Algebra 1 talking about slope. So M is the letter we use for it. We call it slope. Another way to think of it is rise over run. So, you count how many units up or down it goes, how many units left or right it goes to calculate your slope. Also, there's a formula for it. If you have the coordinates, this is the one that's the y2 minus y1 over x2 minus x1. And that should be all review. So that's kind of just like a list of formulas or way to think about rate of change or slope. Again, those words all kind of mean the same thing. Now, what we're going to do, we're going to look at specific graphs, and we're going to say, over a certain interval, what is the rate of change? So we're going to start with a really basic one. So down here on example B, this gives us 3 different graphs, and it says on each of these graphs, what's the rate of change on each of these specific intervals? So this is actually like 9 problems in one, because you got 3 graphs, 3 intervals each. So let's just look at this first graph. This is a super simple graph. This is a graph that is constant the entire time. Doesn't go up, doesn't go down, it just stays flat. This is about as easy as it can get. So let's answer the question though. It says, what is the rate of change on each of these intervals? So from -2 to 0, remember these are x values. When we're talking intervals, they're saying from when x is -2 to when x is 0, what is the rate of change? So when x is -2, that's this point on the graph right here. When x is 0, that's this point. So they're asking us for the rate of change between those 2 points. Let's just think of this in terms of rise over run. As you go from this point to this point, it does not rise at all. The rise is 0. The run is 2. So if you're thinking of the slope here, it's 0 over 2, a rise of 0, a run of 2, which of course is just 0. And if you remember how lines work, especially horizontal lines, this should make sense to you because the slope of a horizontal line is 0. It doesn't go up at all. It just goes over. So it doesn't even matter what interval we look at. It says here, look at the interval from 0 to 3. Well, guess what? When you go from the coordinate at 0 to the coordinate at 3, the rate of change is still just 0 because this is just a flat, constant line. So this is a very, very easy example where no matter what interval you look at, the rate of change is going to just stay 0 because that line does the same thing all the time. It's flat, it's horizontal the entire time. Okay, so that's a pretty straightforward one. Let's jump to this next one. So this one, you have the g of x or like y equals 1/2 x minus 1. So you probably remember doing a whole lot of y equals mx plus b back in the Algebra 1 days. Okay, remember how that's the slope and that's the y-intercept? Right away looking at this, you know the slope. The slope is 1/2. And guess what? In a line, it's always 1/2. It's always going up 1, right 2, up 1, right 2, up 1, right 2 all the time. So what you're going to notice here is that rate of change is going to stay the same all the time. So let's just look at our interval here. From -2 to 0, what does this graph do? At -2, we're at this point. And when x is 0, we're at this point. If you count the rate of change between these 2 points, you go up 1 and right 2, which of course, 1 over 2 is just 1/2. So the rate of change of this graph on that interval is 1/2. But if you pick it on any interval, you're going to see it's the same exact thing. So again, let's look at this one. This one says from 0 to 3. What happens? At 0, we're here. And at 3, we're here. So if we take the rate of change between those points, this time it goes up 1.5 and right 3. So 1.5 over 3, that still simplifies to 1 over 2. And you get the same exact thing. So that's because this is just linear. This graph is doing the exact same thing all of the time. Even if you took the last interval, just for proving it here, from -2 to 3. If you're here at -2 and you go to this point up here at 3, you're going to go up 2.5 and you're going to go right 5. So again, 2.5 over 5 still just simplifies to 1 over 2. And the big takeaway here is that's how all lines work. If anything's a straight line, whether it's constant or an increasing, or if you had one with a decreasing slope, the slope's the same everywhere you look. It doesn't matter what interval you look at, what you do, it never changes. That's the beauty of linear functions. Algebra 2, we don't do a ton of linear functions. We're going to see them, but we spend a whole lot more time with nonlinear functions, functions that have curves and little wiggles and do weird stuff to them, okay? These, the intervals really do matter. You're going to notice this one does not have the same rate of change ever. It's different everywhere you look. So now this is kind of the more important example. So this says from -2 to 0, what's the rate of change? So here's my point at -2 right here, and here's my point at 0. So what's my rate of change there? Notice the scale goes by 2s, so I actually go down 4 and right 2. So down 4 and right 2, rise over run would give me a slope of -2 there. And that actually makes sense because from this point to this point, it's definitely going downward, so a negative slope makes sense. Okay, cool. So we did that. We found the rate of change between those 2 points, that interval there. But let's look at the other ones. So now the other interval here says 0 to 3. So from this point that's at 0 to this point that's up here at 3. So what's the rate of change there? My rise would be, it goes up 9 and right 3. Up 9, right 3. So 9 over 3, and that reduces to 3. Obviously, that's a different rate of change because now that graph's heading upward. It's positive. It had a negative slope here. It has a positive slope as it turns and starts increasing. Okay? The final interval says what happens from -2 to 3. What's the rate of change there? So if we start at this point here that's at -2, and now we want to go to this point that's at 3, it's like from here to here. So it should be positive. Let's check. So if we go from 4 up to a 9, that's going up 5. It's also going from -2 to 3, that's going right 5. So we're going up 5 and right 5, 5 over 5, for a rate of change of 1. So the point to be made here is that when you do rate of change on an interval, look at the shape of the graph. If it's linear, then it's going to be the same no matter what interval you pick, like it was in both of these. But if your graph has any kind of curves to it, then you are going to have to individually calculate each one. And again, just use rise over run there. Count how many units up or up or down and how many units left or right it goes, and that's how you're going to figure those out.